about the continuous delivery. Okay, so how the continuous delivery will work. How the continuous delivery will work. So in the last session, we discussed about what is the Devops, so how the Devops will work, and what are the tools we discussed during our sessions. Okay, those things we discussed. But today's agenda, we are going to discuss about continuous delivery. Okay, what is the meaning of continuous delivery? This is very important. Continuous delivery. So mostly people are hearing this one. Okay, continuous delivery. Okay, so before understanding the continuous delivery, so we are going to discuss about the use cases. So in organization level, so we already know that, right? We already know in the organization level we have different types of right. Okay, so in that scenario, continuous delivery will help us. So let us take, we already know the different types of environment, like say, if you say the developer environment, dev environment, development environment, qual environment, certain environment, and production environment, right? So we have four different types of environment. So I'm just saying in the generally, but in organization level, so organization by organization, so the environments will be different. See, for every environment, and we are deploying our application. We are deploying our application, and to make sure the server should be more than one server. So they are maintaining more than one server for the high availability. More than one server for the high availability. Yes. Oh, right. Okay. So development, qual, certain production. Now the point is, see, we already on the continuous integration side, so we are automated everything. But how we can able to deliver? So how we can able to deliver in each and every server and each and every environment to make sure our application should be up and running. That is our main point. So for this, so let me explain one small use case we can understand very clearly. Let us suppose, so we are having four servers. Let us suppose we are having four servers in the environment. So I'm taking like this: one, two, three, and four. Okay, so these are the four servers I am taking for one environment. Either it should be production, either it should be production, or whatever you want. Okay, and let us take, we have the web server 1, web server 2, right? Web server 3, and web server 4. Server 4, right? So we have the four type of web servers. So I want to configure my entire workspace. If I want to configure entire workspace, what are the things we need to do, Ram? Suppose you have to make sure you need to process all the configuration. So what are the things you need to take care when we are set up your application? Any idea, Arvind?
Sorry, you're
Suppose
saying something?
no. Right now we have the one server, right? We have the four server. For one server, if I want to make my application is ready, whenever my application is ready, so what are the things we need to do? So first of all, you need to make a workspace is ready, right? Workspace is ready is nothing but, so to get all softwares, to get all the softwares, to get all the softwares, and to operating system, operating system configuration, and get all the softwares, and to deploy the code and integrate middleware services, or and configure middleware services, or we can say that integrate middleware services, right? So these are the things are available, right? So same process we have to do in the web server 2, web server 3, web server 3. Can you tell me, if I want to do this process, how much time it will take? How much time it will take if you want to do this process?
let's say uh, operating system and everything 2 hours. Let's by default take 2 hours. So 2 into 4.
2 hours, right? 2 hours, right? So maybe 2 hours. Suppose if I want to do same process, if I want to do same process in another server also, so maybe 2 hours more than the 2 hours. Why? Because see, when we are doing the same process, when we are doing the same kind of process in another server, maybe it is taking more time, maybe it is taking less time. So due to the code compatibility and due to the version compatibility, correct? Yes or no? So you already know that. Suppose when we are setting the application, when we are setting in our application, sometimes it is working fine, sometimes it is not working. So again, it may take 2 hours or it more than that to set up this process. Like see web server 3, web server 4. Let us suppose if you are having 10 servers. So for each and every server, we have to log in, and each and every server, we have to set up all kind of workspaces, and it will take 2 hours or more than that. So in this scenario, in this scenario, how we can able to handle this situation? How we can able to handle this situation? Can anyone tell me your idea?
Maybe do the automation kind of thing.
Sorry.
Maybe we can do automation in other in all servers.
Exactly. See, whenever the problem, see, blindly remember one point, guys. Okay. So initially in the continuous integration side, in the continuous integration side, so whatever the manual stacks, the DevOps engineer are automated. The same way, the same way here also, when the problems occurred, so when the problems occur, our DevOps engineer is the responsible to take sure to make sure everything is going smooth and everything is working fine. So here what happened? So whatever the things, what are the things we have to do? Everything we have to convert into single unit. We have to convert into one snap or one image. Let me explain. So let us suppose. So if we are layman example, so this is a web server one, web server, web server. Let us assume. So this is our LB Nagar, or we can say Dilshuk Nagar. Okay, and we have Amirpet. We kept the servers here. Okay, and KBHP, and here we kept them into the BHL. Okay, so these are the four servers we kept it there. So let us suppose these inside the configuration. Let us take this is the things. This is the goods. Okay, inside the configuration we can say that these are the goods. Okay, so how we can able to transport? How we can able to transport our goods here? So we have to send via container. Correct na? Yes or no? So if I want to moving the goods from one location to another location, we have to keep them into the container, right? So what they can do,
Yes.
we have to combine all the things into the, we have to package each and everything, and we have to keep them into the container. The container is responsible to moving. So the container will keep all the things to Amirpet server, Amirpet server, and KPHP and BHL. See, here if we take, otherwise, if I want to do it everything into manually, it's very difficult. If I want to moving the items for one by one good, it's very difficult. So instead of that, what they can do, they whatever the application configuration, they have to combine into one single unit, and they are sending via container. The same way, the application also. So whatever the manual process, whatever the manual actions we are doing in the application delivery, so we have to combine into image. Just simply we are running this image inside the container. That's it. So within fraction of second, your application is available inside the container only. It can contains the built-in operating system, and it can contains the all configuration while we are deploying your application. Maybe it can contains so code. Maybe it can contains deploy into the Tomcat server or etc. Whatever you want. Okay, so this is called it as a continuous delivery to make sure. So to make sure everything should be the automated. So here one more doubt you have, sir. We are not installed physically. We are using the container. So is it necessary for four servers? Is it necessary for the four servers? It's not required. See here, one server is enough, guys. See, one server is enough. So let us say, so because every container, every image is working as a independent. Every image is working as independent. So why I need to take four servers? So within single server also, I can able to manage four independent images because it's the same application, right? Why we are deploying same application to four server for high availability? Even if one application is down, so still our application is available. The because of same concept. But here we are not installing physically. We are inside the image. We are maintaining everything. Same thing. One, two, three, four. Right. So we have the four images. One, two, three, four. Right. One, two, three, four. So here, what is an advantage here within single server? Within single server, we are deploying four different types of identical images, and the infrastructure cost is reduced to 70%. The infrastructure cost is reduced to 70%. And one more important, so whatever the image we created now, we can keep that image into some secure location that is called as a hubs. We have the Docker Hub business. So, what is the responsible for the Docker Hub here? Why the Docker will come into the picture? Docker is responsible for two things. One is for whatever the configuration is used, whatever the configurations are using in our application level. So it should be converted into the images, and this is the raw images, and these images we are running inside the container. Docker will provide the containers. Inside the container the image will be running. The image, what is the life cycle? What is the life cycle of the image? Life cycle is nothing but from while using, so the container will be responsible to take care about the life cycle of the image. That's it. So let me explain the same process in the CI/CD flow. So how we are delivering our application? So here the Docker is responsible, and there is a one more thing, orchestration. So Docker and Kubernetes is the major tools. Docker and Kubernetes is the major tools working on the continuous delivery. So in the continuous delivery, what Docker is responsible for creating the images, running the images inside the container. What is the Kubernetes? Orchestration, scalability, availability, deployment. So for all these kind of activities, we can go for the Kubernetes. But how the Kubernetes will work? Usually, I'm showing a small diagram. You can understand clearly how the Kubernetes will work. Okay, so within fraction of seconds. Okay, within fraction of seconds, your application should be deployed. Your application should be clear. Everyone, as of now, Ram, Karthik, Arvind, clear?
Yes, yes, yes.
Okay, fine. So now the same process, how the Kubernetes will do. The Kubernetes part, what Kubernetes can do. So whatever the image is created by Docker, na, that should be orchestrated into different types of the environment. So let us suppose we are having two different. Let us suppose we have the two servers are available. Okay, within the two servers, I want to deploy my application. So here it is working as a master slave architecture. Orchestration. Please make sure orchestration tools are nothing but so if you take Ansible, if you take the Puppet, or if you take Kubernetes, these are the orchestration tools. Okay, so it will connect as a cluster. Whatever the servers, it will be connected as a cluster like this. Okay, like this. So here, what happened? Usually, what happened? Docker is responsible for to convert the image. We are kept into the Docker hub. Let us suppose this is your Docker hub. This is your Docker hub. So we are keeping our Docker images. Okay, we are keeping the Docker image. So immediately, what Kubernetes can do? This is the master. This is the slaves. One, two. Okay, highly I can do. So whenever we are deploying our application, we just created one kind of deployment file. Deployment file. Don't worry about it. I'm just saying the architecture, or we can say high level. So how the process will work. Okay. So when we are executing the deployment, automatically the deployment will use this image, and automatically this image will orchestrating with the immediately within fraction of seconds. Your image will be deployed into all the servers. Your application will be deployed into all the servers. Okay, this is called as orchestration, and this is a deployment. Suppose if we get any issue, let us suppose due to some issue, your this pod is not working, this container is not working. Don't worry about it. Kubernetes will be automatically recreated. Okay, Kubernetes will be recreated. So this is very, very important. Okay, so now I'm going to explain the typical flow of CI/CD process. So 99% of the people are confusing here CI/CD, but in our sessions you guys easily understand continuous integration the thing. But whatever the up to the testing, if I want to automate each and every process, that is called as a continuous integration. Continuous delivery, what is the meaning of delivery? So different types of environments are there, right? Different types of environments are there, and different types of servers are there. If I want to deliver your application, if I want to deliver your application number of server, and to make the consistency, to make the consistency, that is called as a continuous delivery. So let me explain the typical flow of the. So I'm sending this diagram, so while seeing the diagram you can easily understand. So that's why we are I'm sending here. Right. And one more here. So typical CI/CD flow, we already know that where we are keeping our application code, where we are keeping our application code. So we are keeping application code into the Git, correct? So Git is responsible to keeping our application code. This is called as a Git. To keep application code. To keep application code. Right. Okay. So when we coming to here, this is called as a Maven. Okay. So to compile, validate, packaging the project. Okay, so this is called it as a Maven is a build tool, guys. Okay, it's a build tool, so it's working on the user. So the packages will be, it should be var file or jar file, var file or jar file. We kept it right. Okay, so I find after that what they can do. We are sending this packages into some artifact tools. We can say that Nexus or JFrog, Nexus or JFrog. Okay, so to keep them into the artifact tools. Mm, Keep them artifact tools. To keep them artifact tools, right? So next one is what we can do. Next one is, so usually what happened once it is completed, we need to check the sonar. Okay, we need to check the sonar cube or anything to check the performance of the code usually for every environment. So sonar, I'm just explaining whatever the continuous integration and delivery tools usually we are using in the organization level. Sonar cloud, we can say sonar cloud or sonar cloud. Okay, so this will help us to get the vulnerabilities, to get vulnerabilities. Okay, right. So after that, so till now, till testing, everything is done, right? So up to before testing, if you want to automate, right? So here, this is the Jenkins, guys. Jenkins is responsible to automate all the process. Once this process is completed, so here the Docker will come into the picture. Next, what Docker can do? Docker is responsible, right? So here Docker, Docker, and here Docker Hub. See here, if you observe, see for code also, for code application code also, we are keeping the GitHub. For repositories, for packages also, we are keeping the Nexus or JFrog. This is also hub. And for Docker images also, we are keeping it to the hub. Okay. So for each and everything, because for reusability, we are keeping into the some kind of repositories. We are keeping some kind of repositories. So this is very important. This is very, very important. Right. So after that, what we can do? So we are going to. I told you right. So we let us suppose these are the four servers. One server one, server two, server three. Okay, three servers are available. Okay, these three servers we are connecting to the cluster. Okay, this is our cluster. One, two, three. Okay, so this is called as a master. We can, for our understanding purpose, Kubernetes master, and these are the actual servers, right? So we can say the web server one, server two, and web server three.
All these happens in only Kubernetes or any cluster it can be performed.
No, no, no. As of now, the Kubernetes is the best tool in the market. Okay, so even Docker Swarm is also be performed, but a single node cluster. Those are the single node cluster. Okay, na? So let's say if you take a Docker Swarm, that is a single node, but the Kubernetes is the best tool in the market. That's why we are going to discuss only for the right now the trending and important tools in the market. Okay, Ram, got it, na?
Okay. Okay.
Clear? Yeah. So even ECS, AWS side, EKS, EKS is also like a Kubernetes also. Okay. And ECS, everything is there. But right now you clear understand our ultimate goal is when the developer commit the code, when the developer commit the code, so automatically my application will be delivered within fraction of seconds to all the servers. Correct? That is our ultimate code. Yes or no?
Yes.
So that's why we are set up all these things like this. Okay, so this is called as Jenkins. What Jenkins can do, it should be automated all the process, it should be automated all the process, right? So first of all, so from git to maven, first step, yeah. So whatever the manual actions, first to get the code from repo, to get code from repository. Second one is to packaging the, to compile and packaging the code. Third one is to send send packages into factory servers. And fourth one is and to the vulnerabilities cloud.
What
Okay.
does Artifactory explain?
No, artifactory nothing but artifactory is nothing but see for technical word. See right now, whatever the code is there, na, it should be compiled and packaged. The packages are jar file or var file. So these things are nothing but artifacts. Okay, so next what they can do, whatever the var file is generated, we are sending the jar file into some secure location that is called as an access and JFrog. Got it, na? Artifactory is nothing but packages. Okay,
Okay, it
finally,
maintains the versions.
sorry,
It maintains the versions.
it contains
Version. Version.
exactly. Exactly.
Okay.
See, let's say if your the application is deploying 1.0 version, right? 1.0 version. So your package is nothing but let's suppose app.web. Okay. So in the Artifactory server, what we can do by version wise, we can it will store the packages. Understand?
Yeah.
Okay. Here app.web colon 1.0. Correct, na? So it will store
Mhm.
like this. Suppose if you get one more version, so app.web 1.1, right? Okay, so whatever the version you want to do, you can able to do that. So fifth one, to check the vulnerabilities afterwards, to convert all configurations into to convert all the configuration into Docker. So how we can go? So ultimately, whatever the packages we are deploying the Nexus or Artifact tools, we are going to deploy Tomcat server. Here we are not doing physically. We can just take a Tomcat image. Inside the Tomcat image, we are deploying them into the our WAR file, and we have to restart the server. So that process we are doing. That process we are automated, and this what they can do. Docker will responsible for to convert the image, and this image it will be stored into the application. This is called it as application. Okay, application. So after that, sixth point. Okay, sixth point, to deploy them into the different server. Pushing into Docker Hub. Okay, seventh one is deploy them into the server. Okay, so immediately what happened? So it like this. First of all, git to Maven to Nexus, like this. After that, it will be like this. So here, here, right. See, up to this one, still Sonar Cube, right? Sonar Cloud. So this entire process is called a continuous integration. So from this one to this one here, the continuous delivery. So when we deploy it here, automatically Kubernetes, what Kubernetes master can do, Kubernetes master will push that application into within with the replicas. Immediately within fraction of second, it should be delivered into these servers. Got it, everyone? Clear this diagram? So this is the typical, we can say architecture, we can say the combination of CA plus CD tools. How the CA plus CD tools will work. So this is the diagram. This we can say the blueprint of this diagram. So while seeing this diagram, you can easily understand. So what are the tool functionality, how it should work. Wh- But in our practical scenario, first we are going to discuss the Git, then Maven, then these are the middleware tools, we can say that. So it's optional. Okay, if you want, you can keep it. So Nexus and JFrog or Sonar, we are also integrated with that, and Jenkins to automate all the manual process. Docker, so to convert all kind of configurations into the images. The main advantage here, in future, suppose all of a sudden your application is down, don't worry, our image is available in the Docker Hub. The Kubernetes will be recreated. That's why orchestration is nothing but scalability, availability, and deployment. This process is called as orchestration. So this is a typical CI/CD diagram. This is the typical CI/CD diagram. This is the typical CI/CD diagram. This is a typical CI/CD diagram. Clear, everyone? Ram, understand? Arvind,
Yeah.
got it, na?
Yes.
Yeah,
Yes.
this is
Yes.
how we can able to. This is how we can able to working on the organization level. So yesterday, Continuous integration we discussed. Today, continuous delivery. Tomorrow, we are going to discuss about understanding about the configuration management and continuous monitoring, and then we are going to start with the practical sessions on each and every tool. Okay, now even we can say this entire whatever the things we discuss, na, I am going to explain this entire process, entire project. We will combine. We will take one sample project. See, nothing is there. What is the developers work? Developers work are only keep the application code to the kit. That's it. So rest of our work is we are going to automate this process, manual actions to automate it. So the developers' lives went smooth. Okay, even our life also went smooth, guys. Okay, so like this you can able to work on it. So tomorrow we are going to see rest of the things. Thank you, guys. Bye. Any doubts, Arvind, from your side? Karthik, Arvind, any
Uh,
doubts?
yeah, but this is Ram. What is the difference between, we have, AWS DevOps and the DevOps in, physical
No, no, no,
clusters?
no,
What?
no. Don't say like that. See,
Mm.
develop functionality is same, but AWS DevOps are nothing. But so only AWS will provide some kind of dependencies, some kind of suppose uh, in the normally in the general DevOps we are using the Jenkins, right? In the AWS
Yeah.
side, code pipelines. AWS will provide a separate service as a pipeline. So AWS DevOps is nothing but AWS DevOps will explain the pure dedicated resources in the AWS environment only. But in our case, how we are explaining the DevOps for the general DevOps. General DevOps is nothing but usually how the organizations are working. And plus,
Okay.
we are discussing the AWS tools, AWS 15 plus tools in the AWS. So that what is an advantage here? We can get the calls for all the organization along with we already know the AWS. Even in somehow in future their organization want to use only for the AWS specific, we know the process. Understand?
Okay. That, we are going to go in depth or just,
No, no, no. Everything is practical based only. So right now, only yesterday only started some kind of. So I'm just explaining the basics. Okay, I'm just explaining how it should work. So each and everything is going to practical. First, we are going to discuss about all the tools individually, and after that, we are going to explain. Understand?
okay.
So here, right, Hari,
Yeah.
are we going? So we are going to in Jenkins. We are going to configure Git, Maven, Access,
Everything.
even
So
Kubernetes.
that's yeah, Kubernetes also. Even Kubernetes also we are going to discuss Kubernetes on premises and Kubernetes cloud, AWS cloud also. AWS the service is EKS. So even I will help you the EKS service as well. Don't worry about whatever the tools we are showing here. So this is only for CI/CD part. We have one more configuration management and continuous monitoring is also be there. From CI/CD part, these are the major important tools. I am going to explain each and everything.
The
From
monitoring part also we are going to go in configuration level.
Yeah, exactly. Monitoring is nothing but see nowadays organizations are moving to the cloud, right, Ram? So cloud
Yeah.
level we have the CloudWatch is there, and EKS level we can go for the Grafana, Prometheus. These tools are very important. So those tools I will explain to you.
Okay. What about Nagios?
Yeah, Nagios is nothing but that is also come to on premises. So Nagios is also same thing. See, you created a server. So how we can able to monitor your application is working or not? We need to set up one monitor. If the monitor is green color, your application is good. If the monitor is red color, the application is bad. Yeah, I will show you the Nagios as well because I am going to explain cloud level resources as well as on premises level resources. That's it. Clear, na, Raf?
Yeah.
Harvind, any questions from your side?
No, I'm good.
Okay.
Hari.
Thank you, guys. Bye.